Spinners are great because they remind me of playing games, and I love games. So you spin a spinner and you see where it lands. And here I have a spinner where I could see the angle made by the various colored sectors. So 120 degrees, 55 degrees, 60 degrees, 25 degrees. This one's actually mysterious purple. And we can actually use those degrees to figure out a variety of probabilities. Let's find the probability that the pointer lands on yellow. Well, I see that out of 360 equally likely, assuming the spinner's fair, equally likely places that the spinner can land, 120 of those degrees are yellow. So the probability of yellow, wow, I should really be using a yellow marker, shouldn't I? Sorry. Probability of yellow equals, well, 120 out of the 360 equally likely possibilities, which is 1/3. And that kind of looks like a third of a pie, doesn't it? So that means that if we do this again and again and again, we would guess that about a third of the time we would be in yellow. Not in yellow. Not in yellow. Yellow. Cool. All right. It won't always happen, by the way, not yellow, not yellow, yellow, but over time we expect to see that on average. So that was just a fantastically lucky, wonderful circumstance where I look good. And that happens so infrequently that I like to grab them. All right, let's now find the probability that the pointer lands on blue or green. Blue or green, those are two mutually exclusive events, which means that they have no overlap. You either are in blue or you're in green. There's no way to be sort of in both, and whatever that is, fuchsia or whatever the color means. So actually, to find the probability of one or the other, we actually just add the probabilities together. So we find the probability of each and then add. So the probability of blue or green equals the probability of blue plus the probability of green. And that's because these events are independent. They're mutually exclusive. So the probability of blue is, well, 55 out of 360, plus the probability of being in green, which is 25 over 360, because that's 25 is the angle formed there. And so when we add these up, what do we see? We see 80 over 360, which if we simplify, we get 2/9. So 2/9, not very high probability, but there again that corresponds to the fact that these aren't very large sectors, so we wouldn't expect that we get in there. Oh, look, I got in there. That's pretty good. I just got into the green, but I don't think I'll do that again. Oh my gosh, I got into the blue. This is like my lucky day. But now I'm in purple. Whew. Anyway, it's not very likely if we keep doing it. I just happen to be fabulously lucky. All right, I should go to a carnival and have someone guess my weight. All right. Let's find one last probability. Let's find that the probability that the pointer is not landing on purple. Well, the way to do this is to actually realize that we could look at the opposite question, because the probability of not purple equals 1 minus the probability of purple. So that would equal 1 minus, and what's the probability of being a purple? Well, we can figure out what that angle is. We know the entire thing is 360, and we can actually add up 120, 55, 60, 25, and we'd see 260, and we know the whole thing is 360, and so we see this angle is 100, so we see 100 over 360. And if we get a common denominator, this is 360 over 360 minus 100 over 360 is 260 over 360, which simplifies to 13 over 18. 13 over 18 is actually kind of close to 1, which means that the probability of not landing on purple is somewhat high. So if I spin this, I'd expect to be more likely that I'm one of these other places than on purple. Let's see how lucky I can be. Not on purple.